Hi everyone, welcome back to physics class. Today is the end of our lesson in topic making measurement. In this topic, we have learned about quantity and unit, measuring length and volume, measuring time, improving precision in measurement, and the last one is the density. In this session, I have 3 word examples. All of these questions is taken from IGCSE past paper test. Okay, let's take a look to the questions. Question number 1. The weight of an object is found using the balance shown in the diagram. The object is put in the left hand pan and various weights are put in the right hand pan. Okay, let's consider that one of the students want to measure the weight of this object and then she used the equal arm balance. Equal arm balance, it means that equal arm balance. It means that we can measure, we can read the result of the measurement when both of these sides are equal. So, if one side is tips down, it means that one side is heavier than the other side. The students then made 2 trials. The first trial, here is the result. She put 0.1 Newton, 0.1 Newton, 0.05 Newton, and 0.02 Newton. So, what's the total weight? For the first trial, she put several magnitude of the weight. She put 0.1 Newton, 0.1 Newton, 0.05 Newton, and 0.02 Newton. Or in other words, she can add, you can add of this weight, you can measure the total weight. The total weight equals to 0.27 Newton. And when she put 0.27 Newton on the right side, the effect is the balance tips down slightly on the left hand side. It means that the left side is heavier than the right side. Or we can conclude that the weight of the object must be larger than 0.27 Newton. And then for the second trial, she put 0.2 Newton, 0.1 Newton, 0.01 Newton. The total of the weight for the second trial, you can add all of this weight. The total weight equals to 0.31 Newton. And the effect when she put this magnitude of weight is the balance tips down slightly on the right hand side. It means that this side is heavier than the left side. So what can we conclude? Yes, you're right. The weight of the object must be smaller than 0.31 Newton. Okay, for the first trial, we can conclude that the weight must be larger than 0.27, and for the second trial, we can conclude that the weight must be smaller than 0.31 Newton. The question asks us to estimate the weight of the object. So, which one is correct? Which one is the choice is correct? A? Is it A? Yes, no, not A, because the weight must be between 0.27 and 0.31. Is it B? Yes, of course, the answer is B. The estimate weight must be between 0.27 and 0.31. So, what's the answer? Yes, you're right. The answer must be B, 0.29 Newton. Okay, let's go to the second questions. For the second questions, here is the question. Pressure is defined as force per unit area. Which of the following expressions represent the dimension of pressure? The keyword of this question is here in the word dimension. If we have to find the dimension, what should we do? Yes, right, we have to analyze the unit. We have to derive its base unit. Okay, let's solve it together. We can write it as pressure defined as force per unit area. And then for the force, we can write it as the result of mass times by the acceleration over area. Then we can write the unit of mass. The unit of mass is in kilogram. Great. And then the unit of the acceleration, yes, you're right, meter per second square. And then divided by the unit of area, yes, you're right, meter square. Or kilogram times meter per second square times 1/meter square. We can cancel meter with this meter square, so the result become kilogram over second square times meter. Yeah. We can write the dimension by using the quantities of this unit. Kilogram itself is the unit of mass, so we can write it as mass, m here, and then second is the unit of time. We can write the quantity of time, and then meter is the, this is t square, and then the last one here meter. Meter is the unit of length, so we can write it as length. So here is the answer. Which one is correct? Oh, we have to make it into the exponent. We can write it as m times t to the power of -2 times L to the power of -1. So which one is the answer? Yes, correct. The answer is A. And now this is the last question, question number 3. In question number 3, here is the question. 4 rectangular blocks P, Q, R, and S are shown. Each block is labeled with its size and its mass. The question is, which 2 blocks have the same density? How to solve this question? Yes, you're right. We have to calculate the density of each block. We can calculate the density by using equation density equals to mass over volume. So we will start from block P. We have to find the density of block P. We can calculate the density of block P by using this equation. The mass of block P itself is 10 gram, and then the volume, because this is cube, we can multiplying all of this side. So the volume equals to 2 times 2 times 2 equals to 8. Here is the density of block P. And then we going to the block Q. We can find the density of block Q by using equation mass over volume. The mass of the block Q equals to 10 gram, and then the volume of block Q equals to, yes, right, 2 times 3 times 2 equals to 12. Next, we're going to block R. For the density of block R, we can find its density by using equation of mass over volume. The mass of block R equals to 20, and its volume equals to 2 times 4 times 2 equals to, yes, great, 16. And the last block is block S. We can find the density by using equation mass over volume. The mass itself is 20 gram. The volume is 2 times 2 times 2 equals to 8. Great. So which block have the same density? Yes, right. The block has the same density is P and R. Yeah. 20 over 16, we can also write it as 10 over 8. We can divide it with 2, and this one is also divided by 2. So this is 10 over 8 and 10 over 8. Yeah. So the answer must be B. Great. Okay, I think that's all our lesson today. If you have any question, please let me know. Thank you for watching. Thank you for listening. See you in next Zoom session. Bye-bye.